In this reaction, we are going to combine magnesium and oxygen to form magnesium oxide. This is a synthesis reaction because two or more substances are being combined to create a new one. First, we're going to take a balance from the instrument shelf and place the balance onto the workbench. We're then going to take a crucible, which is going to be the container that holds our magnesium. We're going to record the initial mass of the crucible, which we can see from the balance is 88 grams. And then we're going to go to the material shelf and add 5 grams of magnesium to the crucible. We're then going to remeasure the combined mass, which we can see is 93 grams. We're then going to go back to the instrument shelf and take a Bunsen burner and place it on the workbench. We then place the crucible onto the Bunsen burner. As you can see, when we do this, a tripod appears along with the gauze to act as support for the crucible. We're going to turn the Bunsen burner onto a low flame and wait 1 to 2 minutes. We use the Bunsen burner because heat acts as the source of energy for the reaction. The magnesium atoms need to reach their activation energy. As we can see from this Princeton Education website, an activation energy needs to be overcome in order for a chemical reaction to occur. Okay, it's been a little bit over a minute. We're now going to turn off the Bunsen burner, make sure it's completely off, and we're going to remove the crucible from the Bunsen burner and allow it to cool for 1 to 2 minutes. Okay, it's been about 1 minute. We're going to now remeasure the new mass of the crucible and the new compound. So we're going to place the crucible back onto the balance. So as we can see, the new balance is 96.289 grams. So as we can see, the mass is increased by about 3.289 grams. This tells us that the new compound formed is larger than the initial element of magnesium.
Here we see the balanced chemical equation of the reaction that just took place. On the left, we can see the reactants, the compounds that undergo change during the reaction. On the right, we have the products, which is what is produced in the reaction. As we can see, 2 moles of magnesium in solid form and 1 mole of oxygen in gas form was combined to create 2 moles of magnesium oxide.